right, continuing on with trig identities. Once again, this will be the last day that we go over a problem or two here real quick, but we have to move onwards. As I have alluded to, I could spend a week to 10 days, but once you start getting to a certain level of going through the problems, I feel that the understanding comprehension will start leveling off, and going another day or two is not going to bring that level of awareness and you know your knowledge of identities to another level. So you have to continue to work at it. And once again, as I've said before, take the opportunities to redo problems. Whenever I say something about a problem, might be a good idea to go ahead and say, do the problem. For example, problem number 14. Take a look at 14 real quick. Once again, these are things, if you have not done it, you should be doing it. Okay, but I'm going to refer back to you a little bit more. We have the secant of x over the sine of x minus the sine of x over cosine of x, bless you. And we want this to equal the cotangent of x. Okay, they're asking you to subtract two fractions. So, subtract two fractions. Well, if you're going to subtract two fractions, get a common denominator. Well, what would be your common denominator? This is the mental aspects that you need to go through, the mental cues you need to go through as you go through these problems. Okay, I have two fractions, I'm being asked to subtract them. This is a type of problem that I don't like these types of problems because, once again, it makes you go back and use some fundamental ideas. How do I get a common denominator? What do I have to do to my denominator to get a common denominator? Okay, this goes back to what we did 2 days ago. And once again, we continue to look at if you had 5 halves minus 1/3. I ask you to subtract them. How do you find a common denominator? Multiply your two denominators together. So you multiply your two denominators together. So we have common denominator of sine x, cosine x. Just take one of each. And once again, this is something that you just doing the problem one time, sitting here and me guiding you through this and me generating the thoughts for you. Okay? Because that's what I'm doing. I'm generating the thoughts for you is one thing. But when you have to do it independently by yourself, that's when you start to struggle a little bit more. So, redoing this problem and going through, okay, what two of these things, I'm subtracting two fractions. How do I subtract them? Get my common denominator and go through the problem. Okay, so what do you do to top and bottom? Multiply top and bottom of the first one. What do you have to multiply top and bottom by in the second fraction? I have sine, so I have sine and sine, so what do I have to multiply here? Here I have cosine, here's my cosine. What do I have to multiply there? So multiply your tops and bottoms by those things. Don't feel that you have to do too much at one time here. Because if you try to do too much at one time, maybe you're going to miss something here. Something that's a little bit easier for you to see. First one, we multiply top and bottom by what, Sammy?
Cosine.
Cosine. Second one, we multiply by sine. Okay, don't feel once again you have to do too many things at one time. Now we can evaluate the first numerator. In the first numerator, you have secant times the cosine. Well, secant times the cosine, what are they of each other? Secants and cosines. They're reciprocals. When you multiply reciprocals, what do you get? 1. So if I want to, I can simplify things down as I go down to my next line here, and I can do these things at one time, okay, because I'm going to have to subtract my two numerators, put it over the denominator. So we multiply these two, they are reciprocal, so we get a value of 1 minus, in the second one we have sine of x times sine of x, which hopefully we now know by doing problems after problems. We have sine x over sine x, or times sine of x. That gives us two of them, or sine squared. Now we can look at the front, the top, and we have 1 minus sine squared, which we can scan down through. 1 minus sine squared is equal to cosine squared. I have cosine squared here, I have sine or cosine. What can I cancel? One of the cosines. This goes with that. Since I have multiplication down here, I'm able to do that. So what we're left with now is cosine of x over sine of x, which is equal to cosine over sine, cotangent. We is done. Okay, once again, another nice little problem I like to do, because it makes us utilize some tools of mathematics going forward. And if you think about fractions and working through fractions and how you deal with fractions, okay, this falls out for you. Okay? Problem number 17 is very similar to problem number 18. We did problem 18 yesterday. So if you look at 18 and you look at 17, you just follow along with what we did in 18 to do number 17. It's almost parallel to it, except for rather than dealing with sines and secants and tangents, you're dealing with cosecant, cosines, and cotangents. But it's the exact same type of problem. Any other quick ones you would like me to look at? I'll do one more if you have a quick one you'd like me to go through, but then we're going to move on. Once again, hopefully, as we went through that problem, as I started going through some little cues, hopefully you're being able to recall a few things as you go through it. Okay? You should be better than you were on Monday. Are some of you there yet? No, you're not probably there yet. But once again, if you have time, go over this problem again. See if you can do it, generate the cues by yourself to be able to get through the problem. Any other ones? Yeah?
Can we do 5 or 11?
5 or 11? Well, let's take a look at 11 real quick. 11, cosine of the fourth t minus sine to the fourth t. And we want this to equal 1 minus 2 sine squared t. X to the fourth minus y to the fourth. We've done this factoring already. But if you need to, redo it. X to the fourth minus y to the fourth. Okay, what would that factor to if I had x to the fourth minus y to the fourth? What's our two factors to that, Chloe? Okay, that's our difference of perfect squares. So we relate that down to cosine to the fourth minus sine to the fourth. Okay, what would be your two factors? Just take that down. Wherever you see an x, put in a cosine. Wherever you see a y, you can put in a sine. Once again, algebraic skills, x to the fourth minus y to the fourth. That's a factoring. Brennan, what did you come up with? Okay, once again, replace with what we have. First one's cosine squared plus sine squared, which is equal to 1. Cosine squared plus sine squared. This will give us a value of 1. So I have 1 times, okay? So it takes us away. So what we are left with is we are now just left with cosine squared t minus sine squared t. Now what we have to take a look at is what we are trying to get to. I have cosine squared minus sine squared, bless you. I want to get to just 1 minus 2 sine squared of t. Well, I got cosine squared and sine squared. What do you need to get rid of? Cosine squared. How do I get rid of cosine squared? Cosine squared is equal to what? 1 minus sine squared. So we have 1 minus sine squared t minus another sine squared t. If we have 1 minus x squared minus another x squared, that simplifies algebraically to what? 1 minus x squared minus x squared. Candle? 1 minus 2x squared. So now we have 1 minus sine squared minus another sine squared. Same idea. Which is what we're trying to get to. We is done. Once again, just going through the magic of me giving you cues is not going to give you greater understanding. You mudding yourself through some of these is where you're going to get more of the understanding. But that takes a little time to do. And sometimes that's a little difficult for us to give up. We better look at our TikToks or our social media stuff rather than maybe going over a problem or two. Okay? Okay, everybody? Okay, as I talked about, you have to make an effort to get some understanding off of this. Just my 40 minutes or my 30 minutes or my 2 problems or 3 problems to go over is not going to make all of a sudden everything appear in your brain. Got to do a little bit of work. In algebra, once again, we have some ideas in regards to types of functions in algebraic world. Two ways of classifying functions is an odd function and an even function. An even function, when we deal with an even function, we get opposite values from the domain, will result in equal values from the range. I put in opposite values from the domain. And when I talk about domain values, these could be x values, theta values. Okay, those are values that you plug in. Those are values from the domain. You plug them in. And you will result in equal values from the range. And when we deal with an odd function, you put in opposite values from the domain, which again, x values, theta values, does not matter. And you will result in opposite values from the range. What I tried to relate this to is evens, opposite gives you equals, the e's match up. And odds, opposite gives you opposites, all the o's match up. Well, we're in trig class here, and when we're in trig class, we just really worry only about trig functions. But if we just look at examples of an even function, y equals x squared. Y equals absolute value of x. These would be algebraic examples of an even function, because if x is equal to 2, x is equal to negative 2, 2 squared and negative 2 squared will result in a value of 4. The absolute value of 2, the absolute value of negative 2 will result in 2. And the easiest way to determine if you have an odd or even function is just trial and error. Put in opposite values and see what you come up with. If I had just x squared, I squared 2, I squared negative 2, I get the same value. Opposite gives you equal values. Odd functions, y equals x, y equals x cubed. Opposite, or these would be opposite functions. X equals 2, y equals 2. X equals negative 2, y equals negative 2. Opposite values of x give you opposite value of y. X equals 2, y equals 2 cubed, which is 8. X equals negative 2, y equals negative 2 cubed, which would be negative 8. Opposite x's give you opposite y's. And those are algebraic examples. Those are algebraic examples to odd and even functions. Well, in the trig world, once again, sine, cosine, and tangents can be odd or even functions. Well, how do I determine if they are odd or even functions? Well, we substitute in opposite values of theta and solve for y. Let's take a look at the sine function. Let's try our sine function. And the easiest value, what I always like to use, is just 30 and negative 30. Plug in 30 and plug in negative 30 into your calculator. What is the sine of 30? What is the sine of negative 30? And keep them both as, one line after the next line in your calculator. I plug in 30 and I plug in negative 30. I'm plugging in opposite values from the domain into the sine function. Is the sine function going to be odd or even? Do we get opposite values for y, or do we get the exact same values for y? Opposites, so this would be an odd function. Y equals sine theta would be odd. How about cosine? Would it be odd or even? Take the cosine of 30, take the cosine of negative 30. What we got? Even. So y equals cosine of theta would be even. How about tangent? Opposite. So that would be An odd function. How about secant? Well, secants are reciprocal to which one, sine or cosine? Cosine. So what it does, it falls right in line. If I have opposite values and then I flip it over and reciprocate it, I'm still going to get opposite values. So y equals secant of theta would be up here. And these would go down here with the sine and the tangent. What I will ask you on the test is I'll give you two functions. I'll say, are these odd or even? Okay, you can do one of two things. You can do one of two things. You can memorize this. I don't like memorization. What I like to memorize is, well, how do I determine if it's odd or even? I plug in 30 or negative 30. If they come up with equal values, they are even. If you come into opposite values, they are odd. O goes with O, E goes with E. Now, everything that we have done and we will always do in our math class, in this math class here, is I will derive why things occur. Okay? Everything that we have done up till now, I derive why things occur. We have one thing that I do not derive because I don't feel it would mathematically benefit you to be able to go through these next 6. Okay? So this is the only time that you will see in this class, I'm just going to give you some formulas and we're going to apply them. Okay? I could go through the proof and it'd take the whole time to go through the proof. And I don't see, once again, the benefit that we get off of that. So we're just going to go through angle additions. Now the problem we have with angle additions, angles A and B are any angles. A and B are any angles. Well, if they're numbers, yes, you're just going to add them together. 10 plus 20, I'm going to get 30. But what we're going to give you is we're going to give you problems that you're going to have applications to these angle additions. And the unfortunate thing is what you have been brainwashed into, programmed to do mathematically, is when you see parentheses there, you distribute the value that's on the outside to both the values that are inside. You've gone through the world if you had 2, 3x plus 4 using your distributive property to give you 6x plus the value of a. 2 times 3 and 2 times 4. That's what you have been programmed to realize when you see parentheses. Problem we run into when we deal with angle additions, it doesn't work that way. So we have 6 formulas that we will go through today that you will once again want to add to your sheet. If you have the sine of a plus b, once again, this is not going to equal the sine of a plus the sine of b. But what it will equal is the sine of a times the cosine of b plus the cosine of a times the sine of b. And when you have subtraction of a minus b, this just turns into a minus in here. Once again, you will not have to put these to memorization. If you have them on your sheet, you can apply them off of your sheet. We have the sine of a plus b is the sine of a times the cosine of b plus the cosine of a times the sine of b. And when you deal with subtraction of sine a minus b, it's the exact same thing except for the plus in the middle turns into a minus. So you have sine a cosine b minus cosine a sine b. Once again, we're going to be dealing more with just applications. The nice thing about this is we will start dealing with numbers again. And it's not just proving trig identities. You'll start dealing with numbers. Students tend to, enjoy this a little bit more. I don't know if you want to say that enjoyment, but it's better than just dealing with the formulas that we were working with. Once again, the derivation of this would take me the rest of the period to be able to get through. And once again, I don't see too much of, oh my goodness. Oh my. We have the cosine of a plus b. Once again, we cannot just distribute this. This is cosine of a times the cosine of b minus the sine a times the sine of b. And when this turns into subtraction, this turns into addition. And then we have pluses in there, or then we have multiplication in between. And when we have tangent, tangent a plus b, we have tangent a plus tangent b on top, and then 1 minus tangent a times the tangent b on the bottom. And then we have subtraction, we just change our signs around again. And once again, these are things that identity sheet that we worked on that you can use as on the test. These should go on there also. With this, we can look at the reciprocal functions. If I have the secant of a plus b, that's just 1 over the cosine of a plus b. So you find the cosine of a plus b and just flip it over. Cosecant, bless you. You can do the same thing with the sine, bless you, squared. Okay, find the exact formula, find the exact value. Now I know you can click it back in your calculator, cosine of 15 degrees, and boom, hit enter and get an answer. But that's not an exact value, that's a decimal approximation. We want to find the exact values for the cosine of 15 degrees. Well, we do not have a 1575 triangle that we can draw up here and have a relationship between the sides, like we did with the 3060 and the 4545. But what we can find exact values for is if I have a 3060 right triangle, we have across from the 30 is a 1, across from the hypotenuse is 2, and across from the 60 is a square root of 3. And with a 4545, we have 1, 1, and square root of 2. These we know we can have exact values for. When I have an angle of 30, 45, or 60, I can find sine, cosine, tangents of those values exactly. Well, if we take a look, we want to find the cosine of 15 degrees. So we have to ask ourselves, What two of those numbers could I either add or subtract to get 15? 30, 45, 60. What can I either add or subtract to get 15? Zach, what do you think? 30, 45, 60. I want to either add or subtract two of those numbers to get 15. Well, I'm asking the question again. I have two numbers, three numbers, 30, 45, 60. I want to add or subtract two of those numbers to get 15. What can I do? 45 minus 30. Some of you may say 60 minus 45. Does not matter. You'll be fine. 45 minus 30 is a value of 15. Now, going to the other side or looking at the sheets, we have cosine of two angles being subtracted. Well, from the front side, when I have two angles being subtracted, cosine A minus B. This is cosine A, cosine B, minus sine A, sine B. Well, my A value is 45. My B value is 30. So we have 45 here. We have 30 here. We have 45 here. We have 30 here. So from our triangles, we could get our four ratios by looking at our triangles. What is the cosine of 45 degrees? Brandon, what's our cosine of 45? 45 degrees, doesn't matter which one you use. What's cosine? From our triangle, what is our cosine of 45 degrees? What's cosine defined to us as? Cosine is defined to us as what? Adjacent over hypotenuse. So what's adjacent? What's hypotenuse? 1 over square root of 2, which rationalizes to what? What's that rationalize to? 1 over square root of 2? Nah. What do we multiply top and bottom by to rationalize this? Radical 2. So we have square root of 2 over 2. Looking at a triangle up there, what is the cosine of 30 degrees? Cosine of 30 degrees would be what? Owen, what's the cosine of 30 up here? What's cosine of 30? Square root of 3 over 2. Sine of 45, same thing. We have square root of 2 over 2. Then we have the sine of B. What is the sine of B? Matthew? Sine of 30 degrees. What is our sine of 30 degrees? Sine is defined to us as what? What's sine defined to us as? So what's opposite 30? What's adjacent 30? How about 1 over 2, opposite over hypotenuse? So we can multiply these together. Orders of operations. Square root of 2 times square root of 3 gives me square root of 6 over 4 plus square root of 2 over 4. We can then combine these together. Square root of 6 plus square root of 2, all over a value of 4. Very quickly, and this will be the diagram that you're going to use in your homework today. Quadrant 1, quadrant 3. You want to draw your triangles in here. Cosine of angle A is 1 over 2 in quadrant 1. So my cosine is, or my sine is 1 over 2. We can use our good old buddy Pythagoras to find the third side, square root of 3. Angle B is in quadrant number 3. The sine of angle B is 3 over 4. I'm sorry, tangent of B is 3 over 4. So that is opposite over adjacent. We have a Pythagorean triple as a value of 5. We go left and we go down with the negative, so we are with the B, so we need to make sure we throw negatives in there. Now, expanding our formula, we have sine A times the cosine of B plus the cosine of A times the sine of B. Expanding our angle addition formulas out. So from our triangles, I look, what is the sine of A? 1 over 2. What is the cosine of B? Negative 4 over 5. What is the cosine of A? Square root of 3 over 2. What is the sine of B? Negative 3 over 5. Using once again our orders of operations, we have negative 4 over 10 plus the negative 3 square root of 3 over 10. So we have negative 4 minus 3 square root of 3 over 10. Okay, your first set of problems in your homework tonight, you'll be utilizing that diagram. You'll be utilizing this diagram. You'll be expanding out like we've done here. Okay, see what you can do. That'll be our working notes for tomorrow. That was the last of the new stuff. Adios. We'll continue to work on this. You'll get better. Have a good day.